This is the screencast for section 6.2, example 8. Substitution in now definite integrals. See, now up to this point we've been using substitution in indefinite integrals. Now we're going to use definite integrals. So they have a lower limit of integration and an upper limit of integration. So we need to evaluate the antiderivative from 0 to pi over 3 now of the tangent of x secant squared x dx. Now yes, tangent and secant squared are related by a derivative, so that's good. That gives me some u substitution room. Let's see, do I want to make u tangent or secant squared? Well, I'm going to be taking the derivative of u, and then that would cancel out with what's in the problem. So I want u to be tangent of x, and I'm going to take the derivative. So du dx is secant squared of x, which means dx is du over secant squared of x. So I'm going to substitute that in. Now, here's the problem. Well, it's not a problem, and the lower limit of integration and the upper limit of integration are now changing. 0 and pi over 3 were what you were supposed to plug in for x. Now we need to plug in a lower limit and upper limit of integration into this function called u. So instead of just 0 and pi over 3, we need to plug those in back into tangent of x, what we called u. So we're going to use the function u of x equals tangent of x to evaluate new lower limits of integration and upper limits of integration. So now we're going to plug in 0 into u to find out what our new lower limit of integration is. So 0 is going to get plugged into tangent of x. And then plug in pi over 3 into u. So pi over 3 is going to get plugged into tangent of x. All right. Next, my secant squareds cancel out, so that's good. So I have the antiderivative of u du. So let's look at that lower limit again. It's u of 0. So the u function that we're calling tangent of x needs to get evaluated at 0. So now that just means I get to plug in 0 directly into u. I was going to plug 0 into tangent of x. Now I'm going to plug 0 into u because u of 0 is still 0. Now the upper limit, I was going to plug in pi over 3 into tangent of x, but now I called this function u tangent of x. So now I need to plug in pi over 3 to u. And if you don't remember how to do that, here's your work. And that would be, so the tangent of pi over 3 is square root 3. So now my lower limit of integration is 0. My upper limit of integration is square root 3. The u values after they were plugged in for x. So pi over 3 still made it in for x. 0 still made it in for x. Now 0 and square root 3 are going to get plugged in for u, the function of x. All right, so let's take the antiderivative. That would be 1/2 u squared. And now we're going to evaluate. We don't need to plug in tangent of x anymore because that would just change the lower and upper limit of integration back to normal, back to 0 and pi over 3. We have evaluated it, so all we have to do is plug it right into u. So now that's going to be 1/2 square root 3 squared minus 1/2 0 squared. Final answer, 3/2. Now just to make sure, I'm going to do that on my calculator, and I do get that the antiderivative from 0 to pi over 3 of tangent of x times secant squared of x dx is 1.5 3/2. So again, the lower limit and upper limit of integration were originally designed to get plugged into x. Once I substitute in a function of x, I have to reevaluate the lower and upper limits by plugging them into that function of x. The now try problem number 55 says make a u substitution and integrate specifically from u of a to u of b. So they are telling you, leave this as a function of u and then plug in your new upper or lower and upper limits of integration. Okay, so we have integral of tangent of x secant squared of x. As you can imagine, u substitution will apply here because the derivative of tangent is secant squared. So I'm going to make u of x our tangent x. So the derivative of u of x, so du dx, is secant squared of x, which means dx, what we have to sub in, will be du over secant squared of x. So I'm going to substitute those in, and I get u, because that was tangent x, times secant squared, that stayed the same. And then dx is now du over secant squared of x. But remember, I'm now using the input variable u, so I can't use negative pi over 4 and 0 anymore. Those were meant to be plugged into x. X is now a part of the u function. So instead, I'm going to evaluate u of negative pi over 4 and u of 0 for my new lower limit of integration and upper limit of integration. Alright, so secant squareds cancel out, yay. And I have the antiderivative of just simply u du, which will be easy to do once I figure out what that lower and upper limit of integration are. So now u of negative pi over 4. So that's tangent of negative pi over 4. If you forget how to do that, negative pi over 4, first of all, is in quadrant 4, and the rest of your work is over here. That will equal negative 1. Now, the upper limit tangent of 0 is simply 0, the sine of 0 over cosine of 0, so 0 over 1. So I'll take that antiderivative and I get 1/2 u squared, now evaluated from negative 1 to 0, because those get to get plugged directly into u. That's how they're designed. So then I have 1/2 times 0 squared minus 1/2 times negative 1 squared, and then I get negative 1/2. Of course, I checked that on my calculator, and I did get that the antiderivative of negative pi over 4 to 0 of tangent of x secant squared dx is negative 1/2.